In this nugget, you and I are going to walk through the solution for troubleshooting ticket number 4. Let's begin. So for ticket number 4, we're going to make sure that PC2 has an IP address, and then verify that we can ping all the way from PC2 all the way through the network to the internet server here at 209.65.200.241. And par for the course, because PC2 is in VLAN 10, and because VLAN 10's HSRP default gateway is being provided by DSW1, I want to rule out any misbehavior by DSW1 for that HSRP address by simply bouncing the VLAN 10 interface here on DSW1. So let's apply those configurations, and then we'll start troubleshooting between PC2 and the internet server. So here on DSW1, we'll go into configuration mode, we'll go into interface config for VLAN 10, and we'll issue a shutdown. And then after a few moments, let's bring it up with the command no shutdown, and then we'll exit out of configuration mode. Then we'll go to PC number 2. On PC number 2, we'll issue the command IP space DHCP, and hopefully, if things are working, we'll get an IP address on the 10.2.1 subnet. So there's our IP address of 10.2.1.6, and our default gateway is 10.2.1.254. And right out of the gate, because we're trying to reach the web server, let's just go ahead and do a trace and see how far we get with the command trace 209.65.200.241. Hey, we're several hops in. That's fantastic. So if we look at our topology and we compare it to the IP addresses, the first hop is the IP address of DSW1. The next hop is the IP address on R4. The next hop is the IP address of R3, and that's where it stops. And it appears, based on this feedback, that R3 is having a little bit of a challenge with reaching the final destination. So we've just taken what could be a huge fault domain, and we've now reduced it down to something at R3 or beyond R3 that's causing the issue. So next, let's go to Mr. Router number 3. Here's router number 3. And let's do a show IP route to take a look at the routing table on router 3. We'll hit the space bar to see the whole table. And the big problem I see here as I look at all these routes, it's got a lot of cool routes, no doubt. But the problem I see is that I don't see any route for 209 anything, and I also do not see a default route on the routing table of R3. So now we have some choices to make. Because R3 doesn't have a default route, we could go to R2 and see if it has a default route, or go to R1. And again, it's just a matter of preference where we'd go to first. And for this ticket, let's jump over to R1 and just see whether or not R1 has a default route to get out to the internet. And if it does, then we can go back to R2 and see if R2 does or doesn't have it and see what possibly is going wrong there. So here at router 1, ooh, we have a whole bunch of messages. Let's take a look. And I see some messages regarding BGP and wrong AS. Alrighty, so there's very likely a problem with BGP. So let's do a show IP route right here on R1 and take a look at the routing table. And because of all these messages coming up to the console, it's pretty hard to keep things straight. So just for a moment, let's do this. Let's turn off, just temporarily, logging to the console so we can work with our show commands and actually see some results. And we'll do that by going into configuration mode, issuing the command no logging console, and then we'll end to get out of configuration mode. And the cool thing is we can always scroll up if we ever want to take a look at any of these messages. So here on R1, let's do a show IP route, and what I'm most interested in is a default route out to the internet. And based on the show IP route here on R1, we don't have one. I do not see, in all of this output, I do not see a default route, and I also don't see a route to the specific subnet that the server is supposed to be on. So if we look at our topology for a moment, this server is at 209.65.200.241/29, which is the .240/29 subnet. So R1 does not have a default route, and it doesn't have a route to that specific subnet either. Also, while we're looking at this, because we had a boatload of BGP messages, let's just take a look at the BGP information. R1 is supposed to be an AS65001, and the ISP router is supposed to be an autonomous system 65002, which would make them external BGP neighbors if they're set up correctly. Now, the fact that we're getting messages back and forth about a BGP problem, that we're just hitting the screen over and over and over again, it's very likely that we have correct IP addresses configured. Meaning R1 is pointing to the correct address of the ISP router, and the ISP within its BGP configuration is pointing to the right IP address for R1. Because if they were pointing to non-existent or incorrect IP addresses, we wouldn't have any type of BGP notifications that there was a problem. It would just be like crickets. if we had an incorrect IP address. So before we look at the config, this is the 209.65.200.224 subnet. It's a /30. R1 is .225, and the ISP router is at .226. So let's go take a look at the configuration on R1 regarding BGP and its neighbor, the ISP router. So here on R1, we'll issue the command show run. I'm going to do pipe section router BGP. And again, if this was a simulator that didn't support pipe and all the rest, we could just do a show run and look for that section of the running config. Here's our router BGP section, router BGP 65001, which is our correct autonomous system number. And we've got a single neighbor statement of neighbor 209.65.200.226. And we're saying that that's remote AS 65001. And I could have sworn the ISP was supposed to be in 65002. And as a result, this looks like a misconfig on R1. Because if the remote AS was 65001, which is the same as our BGP autonomous system number, that would be an I BGP neighbor as opposed to an external E BGP neighbor. And if we scroll up in this output and take a look at some of the messages that came in, it's also screaming at us regarding these BGP notifications that the peer is in the wrong AS. So we're saying we believe the peer is in 65001, but the peer is saying, hey, no, I'm not. I'm in 65002, and I'm not going to form a BGP neighborship with you because that's a misconfiguration problem. Let's correct this problem here on R1. So on R1, we'll go into configuration mode. We'll go into router config for BGP 65001, and we'll remove the incorrect neighbor statement that says our neighbor is in 65001. So he's no longer a neighbor. And now, let's put in the correct neighbor statement that refers to our good buddy, Mr. ISP at 209.65.200.226 as being in the remote-AS of 65002. And while we're at it, let's go ahead and enable logging again by using the command in global config logging space console. And that way we can see our console messages once again, now that they're not streaming at us because of our misconfiguration. So if we use the command show IP BGP summary, that will help us identify whether or not we have a healthy neighborship. And it looks like we do. So we're neighbors with the .226 address. That neighbor's in autonomous system 65002. And check this out. We have received two prefixes, two routes, if you will, from BGP from that neighbor. Now, there are some transitional commands in the world of BGP. For example, if we didn't want to use the command show IP BGP summary, which is the way we've been doing it for decades, we could use the command show BGP IPv4 unicast summary, and guess what? It'll give us the same output. And as we started working with additional features in BGP, such as layer 3 VPNs, which have VPN v4 addresses that are being advertised and carried in BGP, we're slowly migrating to a different set of commands that help support a wider range of features. And if we want to see the contents of the BGP table right here on R1, we can use the command show IP BGP. And we are learning from our BGP neighbor, the network 209.65.200.240/29. And we're also learning about a default route from our BGP neighbor. So if we issue the command show IP route now, we should have a default route in addition to that .240/29 network in our routing table. And there they are. So there's our default route that we learned via BGP, made it to the routing table. And here's the specific route for the .240 subnet. And even if we didn't get that highlighted route via BGP, we still have the default route that we got via BGP, and that would also be enough to forward the packet in the right direction. So now that R1 has a default route, if R1 is advertising a default route into OSPF, if R4 is redistributing the OSPF into EIGRP, that would make DSW1 and DSW2 aware of a default route. And if that's the case, PC2, which is using DSW1 as a default gateway, courtesy of HSRP that's running on DSW1 for VLAN 10, a packet that PC2 is now sending into the network that's destined to the server IP address should now be routed through the network. And that's assuming everything else is currently working correctly. So to test this, we could go back to PC2 and just ping the final destination. But on the way back, let's just pause just for a moment at DSW1. We'll do a show IP route and ask it to show us all the EIGRP learned routes just to verify that we have a default route present on DSW1. And then if it does, it's extremely likely that PC2 is going to have success in reaching the internet server. So here on distribution switch number 1, let's go ahead and issue the command show IP route EIGRP. That'll make the output a little bit thinner, as opposed to looking at the entire routing table. And sure enough, right there, we have an external EIGRP route, a default route, and the next hop is 10.1.4.5, which is our 4's IP address. That's great. And as a result of this, if we go over to PC number 2 now, and we simply use the up arrow to do that trace one more time to 209.65.200.241, which is the IP address of the internet server, and press enter, hopefully we'll have a full path all the way there. And if we do a ping to that same destination, we should have success with all those pings as well. For troubleshooting ticket number 4, the fault domain was R1, the technology was BGP and IPv4 routing. We had a misconfigured neighbor statement in the router configuration for BGP on R1, and the solution was to replace that incorrect neighbor statement in BGP with the correct one. I'm glad you joined me for this walkthrough for troubleshooting ticket number 4. I hope this has been informative for you, and I'd like to thank you for viewing.